Okay, so the data link layer is the sixth layer of the OSI model. Okay, the bottom second layer of the OSI model, and it is a very important layer, especially for local area network. Ethernet that you guys have heard of many times, it works with the data link layer. Okay, so let's see what's in. So this is what we're going to cover: purpose of the data link layer. Okay, what is the topologies, different WAN and LAN topologies, and the data link frame. Frames are also very important when you're monitoring network traffic for the purpose of troubleshooting. Okay, so understanding frame will help you to troubleshoot network problems, and that's are also linked to data link layer frames. Okay, so let's say, what is the purpose of the data link layer? So data link layer is actually responsible for communication between devices. Okay, so from NIC to another NIC, so that is an important job. Okay, so the network interface card are the data link layer devices, because every software, every hardware, they're related to a specific layer of the OSI model. Okay, so that's the whole purpose of the OSI model, to divide all the functionality of networking. So the data link, so network card is the data link layer devices, and it also allows upper layer of the OSI model, for example, network layer, transport layer, other layer, to access the physical media, okay, which is your cables or wireless signals. Okay, and it also encapsulates layer 3 packets. Layer 3 packets you will learn when we talk about layer network layer later on. Layer 3 packets deals with the IP addresses, either IP version 4 or IP version 6. And one of the most important thing that data link layer provides is error detection. Okay, and it also discard corrupt frames, meaning frames that are not that are corrupted or distorted, or there's a frame with problems, because these frames can cause network issues, either if the network is slow or the network is down, whatever the problem in the network, these the frames can be the cause of that problem. So it also performs error detections. So this is you see layer 2 header. So you have a typical frame. Okay, there are more fields in the frame, but here you have layer 3, which is network layer that deals with the IP addresses. So layer 3 field includes source IP address and destination IP address. And layer 2 field, or the header, include the destination NIC or the source NIC address, which is the MAC address. All right, so as you can see, this is so this is the standards of IEEE 802, okay, for local area network, and MAN is municipal area network. Well, this term is it's not used as commonly as the local area network. Okay, So IEEE, IEEE, which is an organization, comes up with the standard. It's responsible to standardize data link layer or data link sublayers. So data link layer has two sublayers, and one of so this is the only layer in a ASI model that is divided into two layers because of the complexity of task. Okay, and these two sublayers are called logical link control (LLC), sorry, and MAC, media access control. So the LLC communicates between the networking software. Okay, it deals with the networking software and link them to the upper layers. And the MAC layer or media access control layer is responsible for data encapsulation and also to access media, mostly like deals with the hardware, deals with hardware. Okay, uh, and we'll talk about data encapsulation, yeah, in the next view. So for now, if in the exam they ask you a question, okay, or even in a job interview they ask you a question, trust me, this question can come up. Okay, because they talk to assess your networking knowledge. In many job interview questions they ask about OSI layers. So data link layers is divided into two sublayers. Okay, LLC and MAC. LLC deals communicates with networking software. Okay, at the upper layers, and MAC sublayers, it encapsulates data and access media. Simple. Okay, so when one device accesses another devices, it can exchange it can go through many different data link layers, many different type of data link layers or technology. uh, uh, for example, I told you Ethernet is a protocol or the technology that works with the data link layer, and it dictates how signals are exchanged between two devices. Okay, it's a protocol. It's a rule. So think of it as rule, like traffic rules. It dictates. So when you're accessing the internet, your packet starts from your computer and it goes to your switch, or in your house, the switch part of your router, because your router, your home router is actually combination of switch and a router. Okay, so it's there are actually two devices that are combined. So your packet goes, so the packet starts, so you're accessing cisco.com Netacad, right? So your packet starts from your computer and it travels to your switch. Okay, that uses Ethernet protocol or Ethernet technology or the rules of Ethernet. Okay. After, because you're accessing the internet, after it goes to the wide area network, internet link, your ISP, which is considered wide area network. So packet from your computer to your switch is local area network. So there are different rules. And then after that, it uses, depending on your internet connection. So I'm just assuming most of if you have Bell connection, so you're using DSL. Uh, uh, so that's a different protocol. That's a different data link protocol, different set of rules. So think of it like every country has their own traffic rules, right? So uh, uh, so the packets in local area network exchanged differently than on the wide area network. That's why, so they experience different type of link layers and media transitions. They can, from source to destination, they can use combination of media. For example, they can use fiber optic, satellite signals, wireless signals, and the copper media. Okay. Okay, so you're all uh, every network is connected to the internet, and the device that is used to connect to the internet is a router. You already know that. So what? So the hop means when a packet goes to from router to router is called hop. So every time a packet jumps from one router to another router, so they're called hop. Okay, so the first router is the hop one, second router is the hop two, and so the packet goes from router to router. And the basic layer 2 functions inside the router. What it does is it accepts frame from the network medium. Okay, it de-encapsulates the frame. Okay, meaning it open the box. Okay, to expose what's inside the packet, what's inside the packet. And then when it find out all the content of the packet, because a typical packet should have the source address, destination address, source IP address, destination IP address. Okay, so when it finds all the necessary information in the packet, it has to re-encapsulate. It has to put it back, or think it has to put it back in the box. Okay, as a new frame. And then it's forwarded to the next segmentation. So this is how access media. This is how access is provided to the media. Encapsulation, encapsulating the information inside the frame. Now, if you're wondering why, I know this information seems boring at this time, but when you actually will apply this knowledge to troubleshoot network problems, either monitoring it, and you can also look at frames, how the frames looks inside, uh, by using network monitoring software such as Wireshark. Wireshark, by the way, is a free software, and well, I suggest those of you, because I have to mention that in every lecture, those of you who wants to work in networking, like wants to have a career in networking, you can Wireshark is a essential tool. Okay, we don't have time to cover the whole Wireshark because this it's out of the scope of this program. But you can still, like, you have the fundamentals to learn on your own. All right, again, so these are the organization, okay, that are responsible for data link layers. The same organization that are also responsible for physical layers are IEEE, NC, ISO, and ITU. Okay. Now, topologies. Let's talk about the physical and logical topologies. So probably you guys have already learned about topologies, right? Am I right? Has it has it been covered in any other module? Physical topology and logical topology?
I think yes. Star, ring.
Okay, exactly. So these so let's just have a quick overview. So physical topology is important. Is the placement of your devices, physical placement of your devices. So even a star topology is your switch that is connected to end devices. This is called a star topology. Now, a star topology, 99.9% of the network uses a star topology. So it's the de facto topology now. The ring topology is an old technology. It uses by token ring network. So there is Ethernet network for the local area network, and also there's another local area technology, meaning a protocol. It's called token ring. Token ring uses a logical ring to exchange signal between devices. Okay, that technology actually was very good, very secure. It had less problem than Ethernet. Uh, but the thing is, because it was very secure, so it was a little bit slower than Ethernet, and everybody wants speed. But that's not the reason that the token ring network became obsolete. Is the reason they became obsolete because it was IBM's proprietary technology. So IBM made a mistake, did not release it for everybody. So in the beginning, that was the reason there was not many development. But who knows? Maybe you go to a company and where you still see token ring. So when you buy a switch, okay, before 10-15 years ago, you can either buy an Ethernet switch or a token ring switch. So they were two different switches, and you needed a device, a gateway. So if you have an Ethernet network and a token ring network, and you want both network to communicate with each other, you needed a device called gateway. Okay. So anyway, so the physical topology is the placement, and this is also important. Placement, just like distance, is important. So if you have a server that is used by, most frequently used by your, let's say, engineering department, so place that server close to the engineering department. Okay, that's why server rooms are in the middle of is in a place where the distance is equal, where the user can access the server equally. Okay, so physical and what is the logical topology, Masood?
This is about IP addresses.
It's about your IP addresses, and also don't forget the name, the naming the devices. So you create a document of your logical topology. You create all the subnets, okay? And yeah, remember, I told you in a network you have to create, you have to divide your network into groups, just like you divide your user into groups. Okay, you also divide your network into groups, and then you create a different subnet for sales group, for engineering group, graphic design group, doesn't matter. And how do you, okay, how do you create groups? Like you create groups, probably in your Windows Server course. What criteria do you use to create groups?
The rights.
Okay, yes, exactly, the rights, the user rights. But what dictates the user right? Why one user has different right than the other user?
Department.
Exactly. Well, in other words, job functionality. So when you create groups on a server, you create groups based on users, what job they're assigned. job functionality, engineering or accounting, because they use different softwares. So they should have, and not just the different software, because they access different type of data. Like engineers should not have access to human resource data. Okay, they should not know what other everybody else is earning. Okay, the salary, benefits, whatever. So that's how you create groups because of the right. So you're 100% right, Shuri. So, and what dictates the rights is their job functionality. When you create groups, network groups, not on the server, to create subnets, I don't know, I explain it to you guys, only four of you in the class. You create groups also based on job functionality, and also the type, the most importantly, the type of software they're using. So, because you don't want graphic designer to slow down the whole network because they exchange large files. Okay. All right. So physical topology, exactly. So that is also, sorry, logical topology, that is also part of the document. So once you start setting up the network, actually you create documents. That's why packet tracer is an important tool, and it goes further. You can actually test your network before you implement it. Okay. So your logical topology consists of all the IP addresses, different subnet, all the, I will show you the logical topology that I created for our network, our department network. uh, okay, it's considered a small network, our department network, but any other network, any other organization you will work for will have the same network structure. Okay, it doesn't matter. It's just if the network is bigger, meaning if there are more users, there will be more subnets, or there will be more switches, or there will be more routers, but the design would be the same. So you have all your IP addresses listed with subnet, with how you created the subnet. Like in our department, our needs, you're all the same, all the students are same, so there's no different between your group and the other group. You use the same resources. Okay, there's no special software that you use compared to the other groups. So what we have to do, so in this case, we created we created subnet based on your physical location, like which room you're in. And now, why did we have to create subnets? It makes management easier. It makes monitoring easier. So for example, I don't know, it's not as big now. I don't know if you guys still download from torrent. Well, I stopped it many years ago, so I don't know. So there was a point students used to, that's when we created the many subnets. We put each class in a different subnet, because if one student is downloading 4 gig of data, and at that time we had, our internet was slower, we had slower internet connection, it slows down the whole network. So I'm just telling you the importance of subnet. Okay, and it was hard to find, okay, who's downloading it, because everybody was in the same network. But when we create subnetted, it's very easy to identify. uh, First of all, if they're downloading something, it only affect that class. So if the class complain, oh, our internet is slow, we know right, okay, somebody is doing something in this class. And with also, since we have a subnet ID, we can easily identify the IP address as well. Okay, so yeah, so that's the importance of logical topology. Okay. Now, this is something, yeah, remember about, I don't know, Yuri was still talking about the cloud, the internet cloud. Okay. So you have LAN topology, then you have WAN topology. Okay. WAN topology is companies uses wide area network mainly. Well, now internet is a necessity, right? But you before, in the beginning of networking, company uses wide area network to connect their branches to each other. Okay. So it's still you have a separate internet connection, and then you have connection to connect different branches or different sites. Okay. If a company is multinational, national, or they have different, like for example, banks have different branches in one city. So how they are connected to each other is very important. Okay. So one of the simplest and most common WAN topology is point to point, meaning uh, for all right, so we have a center. Let's say person have different center all over the city. So how our central machine is connected to the head office, which is in Dorval. Okay, so it could be point to point, which is very common, and it's a dedicated line that ISP provides, most expensive but most secure. Okay. Especially if the data security is important, for example, bank, because as you know now, data can be stolen while it's traveling on wire. So for example, using Wireshark. Okay. So if the point to point link is a dedicated link between these two sites. Now, other is hub and spoke. It's similar to topology, where a central site, for example, the head office, interconnects branch sites. So that's the hub and spoke topology is being used for the school board. Okay. Point to point, sorry, I give you the wrong example of the school board. Point to point is when there are only, mostly when there are two branches. There's a head office and there's a sub office. Okay. So mostly hub and spoke is one central site is connect, like perfect example of the our school board, where head office is connected to uh, different centers all over the city. Now there's a mesh topology. Okay. Mesh topology is just like hub and spoke, but the thing is there are there are multiple connection. Instead of just one connection to one side, there are multiple connection. Why? What is the reason of multiple connection? Is to provide redundancy, meaning if one connection fails, the other connection is still functional, so people will not suffer the downtime, and the network is still available to all the users, even though if the link is down. Now, this is the most expensive topology, obviously, but it is used by companies that are where the high availability of network is important. So here, this is the physical point-to-point topology directly connected to nodes. Do you guys know what nodes mean? Any device is called nodes. Computer can be called node, switch, router. There, so that's the term that is being used. So here, They're connected. So think of this as in Montreal, and this is Toronto. This is the ISP's network, and they create a dedicated link for you to access between two devices. Okay, and the protocol that is used here is different. Those of you who wants to pursue CCNA, so this is the first. Uh, so there are 3 semesters to prepare you for your CCNA exam. Semester 3 uh, heavily discuss when it's all about wide area network. So you'll learn all kind of different wide area network technology and how to configure devices on wide area network. All right, so yeah, these are the different physical topologies. Star, extended star is just multiple devices. Bus topology, obsolete. No, you will never gonna see this topology, okay? And you have ring topology. So this is, don't think that all the devices are like placed as a ring. This is logical ring, meaning it's a switch and the ring is inside the switch. So this circle that you see, the ring is inside the switch, okay? And I don't know, I haven't seen the ring topology in many years. Maybe, who knows, somebody's still using it, okay? By the way, bus topology use coax cable, again obsolete. All right, half duplex and full duplex communication. Again, probably you guys already know that half duplex is only one way. Okay, uh, send or receive one at a time. Again, this is obsolete. All the devices, if any device that is 5 6 years old uses full duplex, meaning send and receive simultaneously. Okay, so if you see the older devices where you can switch between half duplex and full duplex, but now I don't I don't think you guys will ever see a half duplex. You will ever work with the half duplex devices. Okay, for example, switches. Okay, now, so since we talk about the rules, what is the Ethernet? You need, again, when computers are communicating with each other, and when I say communicating, meaning when you are accessing, so there's a, let's say there's a database server in your company that hosts data, and all the accountant has to access this database server. So let's say there are 10 accountant, right? So they are actually, they're competing for the access to the server. Okay, basically. Okay, so it's just like so you have to have certain rules to prevent uh, to prevent collusion, first of all, that these signals, because they're sending the signals to the server, right, to get the information. So for you have to have rules to make sure these signals don't collide with each other. Collusion, just like on just like cars, when one car when there's an accident, when a car collides with another car, what does happen? uh, 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 it disrupts the traffic. Okay, if it's on freeway, the freeway access is closed and everything's come to an to an halt. Same thing happens on the network, believe it or not. When signal collides, it can bring down the whole network, slow down the network, either slow down the network, but most probably bring down the whole network. So there has to be certain rules. One of the rule that Ethernet uses is called CSMACD. Okay. And what it does is CSMACD carrier sends multiple access with collusion detection, meaning a device has to wait before it sends the signal. No, sorry, wait. So a device sends the cable to see if there's any other signal traveling on the cable. If there is a signal, already a signal using the media, it waits for the random period of time. Okay. And then it's try again and it try again. It happens in nanosecond, right? But that's how different computers are able to communicate with each other. So this is to avoid collusion. That's why it's called CSMACD, collusion detection or collusion avoidance. Okay. So this is one of the access method on local area network. The other method is controlled access. I'm not going to go into the detail because it's legacy. It's not being used as much. So again, it's used by token ring network, where each computer has its own time. So that's why there's no collusion. So there's a token circulating in the network, and each computer has to possess that token in order to communicate. So like you said, you guys already learned this. So yeah, this is the control access. So troubleshooting, these two different, the troubleshooting techniques are different in these two networks. So yeah, I already explained it to you. Okay, it's used mostly. So there is CSMA CD and there's MAC collusion detection process. So the devices detect the collision, and then they wait random period of time, and then they retransmit data. Okay. Okay. CSMA CA is collusion avoidance, meaning it avoids the collusion. Okay. So CSMACA works with the first of all, it only works with the duplex mode, where only one device can send signals or receive signals, and it uses collusion avoidance when it send and receive signals. Okay, so it's basically the same as collusion detection. Okay, as the name implies, frame is a frame. What it does is it frames the information. Like picture is framed, like pictures is inside the frame. So the packets, there's a lot of information that is needed to send a packet from source to the destination. Okay, and all this information is encapsulated or framed. Okay, so a typical frame has header, data, trailer. Okay. Now somebody asked me, okay, that they want to learn more about Wireshark. Okay, and I told you, Wireshark is an application. Learning the application is easy. The features of like how to choose a specific network card, how to stop monitoring, how to start monitoring is very simple. The real job is understanding the information that it collects, and that information is this, what's inside the frame, and that comes with reading more knowledge. Okay, so you can detect a problem, avoid a problem, by reading the frames, what's inside. So again, understanding every field of a frame is beyond the scope of this whole program. But those of you who are curious, you can, yeah, you have the knowledge to read further. So a frame has header, data, trailer. We'll talk about this later. So there are different fields in every frame. So for for the purpose of this course, you don't have to understand every field in the frame. Okay, so here's just a summary. You don't need to memorize it. They're not going to ask you an exam. It's just to give you an idea what a frame is and what it looks like and what's included. So you see, so there are millions of frame traveling on the so also think of frame as a suitcase that, or sorry, an envelope that has multiple information. Okay, so it has frame start and stop, meaning when the frame starts and when it stops. Now, how do you, and this is important, all these fields are important to troubleshoot network problems or to use Wireshark effectively. So for example, frame start and identifies beginning and end of the frame. So each technology uses different size. So for example, if Ethernet uses, I'm just throwing numbers because I don't remember what exactly the size of Ethernet frame. So let's say, for example, if the size of Ethernet frame is 60 kilobits, but you see it's more than 60 kilobit or less than 60 kilobit, that means there's a problem in the network. Okay, and what is the problem? Then you have to figure it out. You have to find the source of the frame, where it's coming from. Is it generated? The problem is software related or the hardware related. So if it's coming from, let's say, the switch, okay, the frame could be malfunctioning port or could be the software in the switch, the protocol. Okay, so what other informations are in the frame? Addressing it, very important. Each a typical frame includes source and the destination address. Type of frame, encapsulated layer 3 protocol or layer 2 protocol. Control, flow control services. The flow control services, meaning the data, the frame is flowing correctly. And also the error detection, if the frame encounter an error or the problem on, so it detects the error, so the node or the computer can resend. Okay, so all this information, so you have to learn about different type of frames. Ethernet uses different frames and the fields are different. Different protocol uses different type of frames. DSL, frame relay, all this. So it's going to be more in, so those of you who wants to study CCNA, okay, it's going to, so this information, you will have more practice about frames in semester 3. Okay, you guys already know that what is a layer 2 address. It is a MAC address, which is and it's only used for the local area network, local delivery. Okay, and a frame includes this MAC address, both the source and the destination. And one of the thing about the MAC address, every time, so keep that in mind. Okay, there will be a question in exam, and this is also important for troubleshooting. Every time a packet goes through a device that has a network card, remember, router's Ethernet interface G0 or F0 is a network card, so therefore they have a MAC address. Okay, so every time a frame pass through a device, the source MAC address changes. Okay, every time it goes through a device with the MAC address. So that's what it means, updated by each device that forwards the frame. Okay, so it's the logical and physical topology that determines the data link protocol used. So these are different type of topology. So you have Ethernet, you have, and then you have wireless, point-to-point link, PPP. Another is high-level data link control, HDLC, and the frame relay. Okay, so these are different. So HDLC, PPP, HDLC, and the frame relay are WAN technology. And these technologies, I don't know who, yeah, Yuri, you were asking me why do you have to use serial interface on a router, and it's much slower. Okay, so the WAN technologies are slower. You won't get 10 gigabit per second. Like, you have Ethernet 10 gigabit per second, but WAN, impossible. So the WAN technology, these are the point-to-point HDLC frame relay. These are the WAN technology, and they're the one that uses serial uh, connection. Some of them uses. All right, so that's the end of the data link layer. I don't know. There's not much. I have to see if there are labs